Earth orbiting satellites are giving us now a truly remarkable picture of our home planet. They show not only regional detail about things happening where we are, where we're standing, but they show how those things that are going on can be seen in a much wider global context. And they tell us then how the different changes that are happening in some parts of the world affect what's going on in other parts of the world. The other great advantage of satellites is that we can get data very rapidly from all over the globe, even in very remote places. The technology for satellites has evolved enormously in recent years. We can now measure a wide range of quantities that are of great interest to our understanding of climate change and environmental change more broadly. And this vital information is giving us precisely the kind of information we need to manage and respond to the big challenges we face on this planet. Climate change, the need to provide food for our growing population, the need to respond to disasters, and the ability to manage the finite resources on our planet. It's a very special time now in the area of Earth observation because we're getting to a point where we're deploying satellites that will sustain measurements of a whole range of properties of the Earth and give us vital and continuous information ongoing in future years.
So we're here on the roof of King's College London, right in the centre of London next to the Thames. And you can see this tower here, which has a number of instruments on the top of it, which are measuring energy fluxes and atmospheric concentrations of carbon dioxide and water vapour. Using these instruments, we can get incredibly detailed pictures of the exchanges of carbon dioxide and energy and water between the different systems of the urban environment. And we can do that at very, very high frequencies, faster than once per second. But these measurements are only being made at this location because it's very complex, expensive and logistically difficult to set up a monitoring station like this. In order to put these measurements in context, we can use aerial remote sensing. So this means putting instrumentation on aircraft and flying them over an environment such as this. Then we can make measurements of the temperature of the different components of the urban environment, the river, the vegetation, the concrete and tarmac that we see, and other measurements like their albedo, for example, how much visible light they reflect. But those measurements are also quite logistically challenging and expensive to make. So the way we can measure much more continuously is to use satellite Earth observation. And this dish here is actually receiving data from a geostationary satellite called Meteosat. That images all of Europe and indeed all of Africa every 15 minutes. The spatial scale of these measurements is quite coarse. Every pixel is about 3 to 5 kilometres on a side. So the whole of London would be covered by only a few dozen pixels perhaps. But we can make those measurements every 15 minutes. And using a combination of these measurements at different scales, point-based, aerial imaging and satellite imaging, then we can put this information into a coherent whole and build up a picture of how this environment is changing and being modified over time. So whilst we can collect highly detailed data at a point and possibly put that in context using information collected by aircraft, we can only do that every so often, whereas information from Earth orbiting satellites is available very, very repetitively over very long timescales. But we can put the point-based measurements that are made at the tower into the context of the whole of London and indeed the whole of the UK. And using these measurements at different scales, we can get both great accuracy, very high temporal resolution, and context.
I'm always inspired by the amazing beauty that emerges from so many different aspects of the natural world. These striking images are not just amazing works of art, but they also capture key details of how our planet works. This image here is an optical image from satellite data off the coast of Antarctica in the Weddell Sea, and what you're seeing in the swirly patterns is the way in which ocean eddies are moving the sea ice around. Those swirling eddies are the same physical processes as create our storm systems in the atmosphere. The difference is that in the atmosphere, the storms are about 1,000 kilometres across, whereas in the ocean here, these features are just 10 kilometres across. Understanding the physical mechanisms associated with them is critical to predicting our future climate. The other images that you see here contain other key information about how the planet works, obtained from other sources of data. Across here we have data coming from ships, And this tells us about the bottom of the sea floor and the features that are found and enable us to understand how that sea floor helps to influence the way in which the ocean moves. And across here we have data coming from aircraft measurements of the vast mountain range that occurs underneath the ice sheets in Antarctica. Understanding the details of this mountain range help us to understand how the Earth has evolved over time, creating such dramatic features. Taken together, these different sources of data from ships, from aircraft and from satellites help to provide a comprehensive description of our planetary system.